Okay. All right, we're going to get started with our webinar. And today you've got myself, Ramji Srinivasan, co-founder and CEO of Teiko, as well as Christina McGee. And we are here to do a live blood draw from our TokuKit. So first, we'll just give you a quick background about the company, then we're going to go into an actual live draw and we'll answer any questions that may be posed. Okay, so just a brief reminder about our mission at Teiko. It's to make high parameter cytometry for clinical trials routine. And this is our here. So I'm Ramji Srinivasan, co-founder and CEO, and this is Christina McGee, Associate Director of Lab Operations. You'll see her shortly. Just a quick refresher of what is it that we do at Teiko. We measure the immune state of patients on trial. So, for example, drug customers can send us specimens of patients on trial, say at a low dose, like 3 mg per kg, and at a high dose, 1 mg per kg. We'll run those blood specimens in our CLIA registered lab. So these are 25 to 40 marker panels, and we'll return reports showing the immune state. So this is a big problem of getting specimens in, and we're going to talk about that in more detail. And all the pricing starts at $12.50 per sample. That's available on teiko.bio/pricing if you're interested later. So what we do is we offer the only end-to-end solution for comprehensive immunophenotyping. So at sample collection, we do a whole blood rapid on-site protocol. This is what we're going to talk about today. We also support cryopreserved PBMCs, peripheral blood mononuclear cells. We've got validated and customizable immune panels. And then we've got an excellent lab here to acquire the data and develop gating strategy that will work directly with your projects. And at the last part of this, we turn this into an easy to read report. So at our base version, you get access to raw data. At our core version, you get statistical analysis and comparisons. In Premier, you get things like machine learning to unlock new supervised subsets. So alternates you could use instead of Teiko is you could try to do everything by hand. And one big roadblock, as we're going to talk about, is the first mile of getting samples on trial. The second part is that there aren't necessarily CLIA validated panels. Third part is acquiring the data. And then the fourth part is having to read this manually via Excel or other spreadsheets. Okay, so why are people picking high dimensional flow in the first place? So if you look at conventional flow compared to higher dimensional offerings, this is a 13 marker panel, this is a 25 marker panel, and a 42 marker panel. The y-axis shows the number of immune subsets analyzed. So this is just counting out all the different subtypes in an immune tree. And over here, you can see there are subsets you would find associated with the response, say potentially CD4 positive naive T cells. But as you bump up the resolution, you can find markers that are associated with response and potentially toxicity as you get to higher and higher subset resolution. So these aren't subsets of academic interest. These are real world, potentially markers that could drive success or failure for a trial. Okay, so that brings us to today's webinar, sample collection. This data is amazing, but if you don't get the first mile problem solved, then you won't see anything downstream. We're going to go through the TokuKit contents. I'm going to read them out to you now, and you're going to see an actual unboxing shortly. This is a two-step whole blood collection kit for immune profiling, so suitable for clinical trial sites that are dispersed all over the world. You don't need any special equipment. You can just use a vacutainer. We support either sodium, heparin, or EDTA. We have a two-step cell preservative system called Stable Lyse and Stable Store, and we're going to go through that. And now after processing, this is crucial, whole blood must be stored on dry ice or at -80 until shipment to Teiko. So don't use -20, don't use anything else other than that. But we'll come to that in a second. So now we're going to switch cameras. So bear with us a second as we go through a quick unboxing. And Christina's going to go through an unboxing of the kit.
All right, hello everybody. I'm going to show you what our TokuKit looks like. It comes in these very handy small boxes that are easily stored at your clinical trial site or by your central lab. Upon opening of the box, you'll find our TokuKit manual that describes the process one more time. You'll find our 2 sample collection kits, 1 for sample collection, 1 for sample preparation, 1 for sample analysis, 1 for sample storage, 1 for sample You'll also find a Ziploc bag with all the kit contents. In there are transfer pipettes that allow for easy transferring of the blood from the vacutainer into the buffers. You'll find a vacutainer, like Ramji mentioned, either sodium heparin or EDTA, depending on your preference. You'll find our buffers. They are clearly marked with buffer 1 and buffer 2 and also color-coded. And then lastly, there's a small absorbent pad in case there's any spillage and a biohazard transport bag to ship the sample back to us.
Great. So now you've just seen all the physical kit contents. Let's go to the shipping conditions. So give us 1 sec. And we're going to show you that as well. All right, so you saw all the physical contents. Before getting started, make sure that you have access to protective equipment according to your institution guidelines. So for example, spatter guards, what have you. And also make sure that you have access to dry ice or a negative ADC freezer. It's crucial to not put this in anything other than dry ice or negative ADC freezer. We've seen samples at negative 20, they get corrupted, it's bad. Trust us, don't do it. So with that, now it's time to draw. So we're gonna head over to the lab. So we're gonna walk over there and get started. So give us a second as we start moving over.
Okay, I'm putting on my PPE. We are ready for the blood draw. We'll start by disinfecting the vein, the area around the vein. Let it dry as we put on the tourniquet. Unboxing my TokuKit to get the vacutainer. We'll be using a sodium heparin vacutainer today. Invert blood, mix that really well with the sodium heparin. And now we're ready for our first step, where we mix the blood with buffer 1, which is the red buffer 1 labeled Nalgene bottle from your kit. I'm going to be using this transfer pipette to measure out 2 mLs of blood. And for this, I'm going to be putting on my safety goggles. Carefully open the tube. I'll take 2 mLs of blood into buffer 1, pipette up and down, discard of the pipette, the leftover vacutainer, close up buffer 1 and invert 10 times to mix it really well. And now we're going to set a timer for 15 minutes to have the blood incubate in buffer 1.
We're just going to go through a quick overview of some of the data and stats behind the TokuKit. All right. So right now, as Christina mentioned, there's going to be a 15-minute waiting period. Rather than show you 15 minutes real time, we're going to go through some of these stats. So here's why we built the TokuKit in the first place. This is a simple sample collection solution for the first mile. When we started the company, we heard a lot about peripheral blood mononuclear cells. Drug developers use them, but it turns out they don't like them. And the reason why is because not only are they hundreds of dollars, but they require special equipment like a centrifugation on site. You just saw we just use a simple blood draw. Cell viability can be variable, anywhere from 13 to 100%. But the advantage is you can get long-term storage. So a lot of times people use fresh blood instead, and this is super fast. You can just get a blood draw, but it requires a physical site in every geography: Japan, Australia, Germany, etc. And so you have to run that sample super quickly, like in 3 days, and as a result, you could potentially lose samples. We've heard 10 to 20% sample loss for, that is, samples that don't arrive within time to be viable. So then there are two other options called Cytochecks BCT and Transfix. These are two very interesting options. For high dimensional panels, there's still a lot of optimization required. These are very interesting, promising alternatives down the road. But this is where we built a TokuKit, where it takes about 20 minutes from vein to complete reaction. The sample is stable for a solid 24 months. So that allows you to do things like batch normalization. There's no special equipment needed, 95% cell viability, $45 cost, and it's easy, fast, and consistent. And you get all access to all granulocyte subsets. So with this kit, you've got 5 hours to start the process. That is from the vein to putting it in buffer 1, as you saw. You've got a solid 5 hours. But once you start that, once you put it in buffer 1, you have 15 minutes to get into buffer 2, and we're going to go to that in a second. Once your reaction is complete, that needs to be placed on dry ice or -80, and then you've got a solid 24 months to analyze. This is a term called post-fixation, so that the reaction is complete. You've got a long time to be able to analyze this on a cytometer, so which is really exciting. We're going to drill down into some of the data. This is pre-fixation stability by major lineage, and this is showing EDTA. And if you can look over here, on the x-axis, you have natural killer cells, dendritic cells, T cells, neutrophils, B cells, monocytes, basophils, eosinophils. On the y-axis, you've got the change from T equals 0. You can see plus or minus 25% is the bar, and we are well within that for this 5-hour period. So if you look down here, 34 out of 34 phenotypes have passed this criteria, and even that's true for 7 and 9 hours. At 27 hours, you start to fail phenotypes. So our guidance to clinical trial sites is to draw and get this done within 5 hours of vein. But really, if you can do it faster, that's better as well. Okay. Excuse me. The mass cytometry mixtures post-fixation are stable for up to 24 months. This is an accelerated stability study we did. We had multiple time points, and we compared 1 week after to 24 months later. And we found really, really tight correlations. So you can see here, this is whole blood process 1 week after freezing and 24 months later. So let's go into this chart in more detail. The x-axis is 1 week after samples processed 1 week after freezing, i.e. 7 days. And the y-axis is 24 months. And the metric here is a percent of non-granulocytes of total cells. So again, apples to apples measures here. And the little colors over here all represent immune cell populations. So we're comparing 1 week to 24 months, and we see a very, very tight, near perfect correlation here. And all of these cell populations had a coefficient of variation of less than 30%. So this is great to see this data, and this gives us a lot of confidence in recommending this. So now let's turn to some frequently asked questions, and we'll also poll the audience in case there's any Q&A as well. But give us a second here as we bring up some of the previously submitted questions and questions that in general drug developers are interested in. And now's a great time to ask any questions you might have. Okay. I'm not able to draw a full 2 ml of blood. What should I do?
So sometimes it's hard to get blood flowing, and sometimes a draw stops before you get the full Vacutainer full. We've tested the TokuKit with different volumes, and you can go as low as 1.2 mLs. So if you don't get the 2 full ml, you can go down to 1.2 ml as well.
Okay. How long can the sample sit at room temperature before being put on dry ice or in a -80C freezer?
So once you've completed the first incubation step and you transfer the blood into buffer 2, we recommend that you immediately proceed and put the sample on dry ice or -80C. However, if you have to walk a little distance to get to that storage, you do have up to 15 minutes from buffer 2 until it needs to be cooled.
Does it have to go on dry ice or negative 80C after the incubation period? And can I put it in negative 20C for a short time?
It does need to go at either minus 80C or on dry ice. This is an important step of the protocol. Please do not use minus 20C.
Yeah, we've seen firsthand the negative 20C corrupts samples, so please do not do that. Okay, what tube holder should I use for freezing? You know, to be honest, I can take this one. People have asked about pre-cooled or pre-chilled tube holders. Those are fine, but really the thing that matters a lot is negative 80C freezer. So make sure to have that handy and at your lab site. Okay.
Right.
See a quick poll to see if we got any questions. Okay, if not, okay. What happens if you leave the blood for too long in the first buffer or you forget to put it in the second buffer?
I think that.
Yeah.
So our protocol specifies that you do need to transfer the blood from buffer 1 to buffer 2 after an incubation period of 15 minutes. If for some reason something happens and you're not able to do that, that voids the sample and it will no longer be valid.
Great. Good questions. Okay, so we are going to head back to the second stage of the reaction, which is buffer 2. So just pretend that 15 minutes has elapsed and you're ready to go to the next stage, from buffer 1 to buffer 2. So, oh, sorry, there's one more Q&A. Did you compare TokuKit to proteomics stabilizer? TokuKit protocol seems quite similar to the proteomics stabilizer. Yes. Well, I guess it is. You're right. This kit is based on stable store. So buffer 1 and buffer 2 are directly from SmartTube. So I think we haven't necessarily done head-to-head comparison because those are the ingredients that we got from them. Oh.
And the proteomic stabilizer Prot 1 is a different fixative that can also be used to preserve cells. However, the two component kit that we're using in this video has a reagent that will stop the fixation reaction after the 15-minute incubation. There's a huge advantage for us in that, so that a fixation reaction can be stopped. But proteomic stabilizer compared to stabilized stable store performs very similarly.
Very good. Okay. Great. Now we're going to go to the second stage of the reaction. So let's just switch our cameras over here. So bear with us a second as we get that going.
All right, so assuming that the 15 minutes have passed, we're now ready to transfer the blood from buffer 1 into buffer 2. To do so, I'm opening up both bottles. I'm going to use the second transfer pipette that was supplied in the kit, and I'll take up all the contents that are now in the bottle of buffer 1 and mix it with the contents of buffer 2. Make sure that the bottle is completely empty. Dispose of your transfer pipette. And again, mix by inverting the bottle 10 times. After it's mixed really well, it's ready to go in the freezer.
So great. Got a quick sense of how this entire flow works from sample to last buffer. You start with the blood draw, you transfer to buffer 1, wait, and then transfer to buffer 2, and then buffer 2 needs to be on negative 80 or dry ice. So we are excited to potentially support any of your immunophenotyping needs. If you have clinical trials, please don't hesitate to reach out after the webinar, or feel free to DM or shoot us an email. And thanks everybody for coming in today. We'll sign off.